Hello everyone, it's Miss Landis here, and today's video is to complete part 1, day 2, I'm calling it, because I'm going to finish out part 1 in the contingency plans. So just showing you what that looks like. In the previous video, we completed up to number 8 in the text, and that is for part 1 of the contingency plans, which should be completed in 1 week. So the second half of part 1 I'm going to be completing in this video. So we'll be finishing out this whole box here up to page 467. The plans are meant to kind of guide you for each week. So by the end of the week, part 1 should be completed, and then next week's videos will deal with part 2 of the contingency plans, which will finish out lesson 1 in the science materials. So lesson 1 is broken apart into 2 different weeks. So in this video, we'll be going through page 462 to 467, completing questions 9, 10, and 11. And then 15 through 19 as well. So I'm going to be going through the packet with you and reading the text, discussing it a little bit to give you some more information. And with some of the photos, I'll be showing you them in my manual, my teacher's book as well, because unfortunately we are, dealing with what was copied, and all of the pictures don't look as detailed as they do in the book because we don't have color. So let me know too if you need your information to log into the Science Online textbook where you can see the photos a little bit clearer. I'll actually just be posting a dojo class story with the information to log on to the science textbook and the website, because I do believe that seeing these photos with color will give you a better idea of what the layers look like. So starting off, we're on page 462. This is Exploration 2 in Lesson 1, and it's layer on layer. So throughout these pages, we'll be discussing different rock layers and what we can find inside of them, and how the way they look helps us understand what was going on in that period in time when they were formed. So we're starting off with telling a story. Mushroom rock from South Africa, which is shown in the photo below, is made of many layers of rocks. Each rock layer formed in a certain way and gives clues about how this part of Earth changed over time. Yesterday I mentioned having a highlighter in order to be able to highlight some important points in the text. So I'm going to be highlighting some things. You could be underlining them as well to help you understand the importance that some of these lines in the text will have in helping us understand the text. So I'm going to underline each rock layer formed in a certain way and gives us clues about how this part of the Earth changed over time. So the important takeaway from that is that rock layers give us clues about how Earth has changed over time. So we're going to examine the mushroom rock from South Africa and use it to help us answer 9, 10, and 11. So starting off with number 9, it says use a thin highlighter or pen to trace the tops and bottoms of as many layers as you can pick out in this photo of mushroom rock. Then number the layers, marking the oldest layer as 1. So I will be showing you how to do that. Just to show you the photo in the book here. And we'll see if that kind of refocuses. I'm not sure why we're out of focus here. There we go. Okay, so looking at the layers in the book, you can see like the color makes a lot more of a difference in noticing the layers. You might see a different amount of layers than I see. So if you would like to right now, you can pause the video on the colored page and use it to help you trace your layers for number 9. So what it wants you to do is outline each layer. So I'll show you an example of that. In looking at the book, I can see like this looks like a layer, and the reason being that the colors are different. So on my page, I might outline this as one layer, as you can kind of see it in the book. So if you would like to, you can pause and try it yourself, but I'm going to go through and just outline the different layers that I see. And it also says marking the oldest layer as 1. Looks like this is a different layer here. I can see another layer here. And then it looks like maybe there's a 4th layer up here. And maybe even with the color changes here, this could be a whole nother layer as well. Now, depending on what you see, your numbers might be a little bit different. So we do want to mark the oldest layer as number 1. Remember, the oldest layer is going to be on the bottom and the youngest layer is on top. In looking at the picture, it's kind of hard to tell because I really see 2 layers that are on the bottom, but it looks to me like this layer is below my layer here because I can see some of that red rock kind of going across the top. So I'm going to mark this one as number 1. In being the oldest. And my youngest layer, I think it's this one all the way up top that's the darkest because it looks like it goes across this lighter brown rock over here. So I'm going to mark this layer here as my last one. So I think this would be 2, or this would be 1. I think this layer would be number 2. This one I'll call number 3. Number 4 stacked on top of 3, and it looks to me like this one is number 5, like it goes across the whole top, and maybe like we just can't see it very well because we can't see the top of Mushroom Rock. You could have less layers than I do. This is just the way that I was able to mark them and see them, and it helps to have the color here as well. So that is our directions for number 9, is to separate the layers and number them. So in answering number 10, let's read the directions here. Some of the rocks that make up Mushroom Rock are millions of years old. The layers have been exposed through weathering and erosion. Those are 2 terms that we haven't discussed in class. Like I said in yesterday's video, the chapter that comes before Unit 7 is all about the Earth's surface, and weathering and erosion are 2 really important vocabulary words that we learn in Unit 6. We didn't do Unit 6, so you probably are unsure what weathering and erosion are. So weathering is the breaking down of rock by wind or water. And erosion So erosion happens. I'm going to kind of get the specific vocabulary term for you. A lot of students could confuse these 2 terms because they do seem very similar. So erosion is the process of moving sediment from one place to another. Instead of the word sediment, I'm going to use process of moving pieces of rock. From, we'll say, place to place. And you can pause and copy these in your book as well. It just helps to understand what that means. In understanding the process of these rocks and fossils and the layers, because we will be talking about how we can tell that weathering and erosion have happened based on what the rock looks like, and that helps us understand that there might have been something previously happening in that rock's life, like an earthquake or some kind of major storm that could have caused the rock to wear away due to weathering and erosion. That could be kind of an effect of a storm or an earthquake. Okay, so for number 10, how many rock layers did you count? I counted 5. You could have counted maybe 3 or 4, but I counted 5, so I'm going to say I counted 5 layers of rock. And number 11 says, what number did you assign to the youngest layer of rock? So my youngest layer is number 5. Your youngest layer could have been number 3 or number 4 if you had less layers, but it should be your biggest number. So just like the newspapers yesterday, day 9 was the youngest newspaper. So for this question, our youngest layer of rock is our highest number. So I assigned the number 5 to my youngest layer of rock. And it doesn't say why, but why would be 5 is the largest number, so it would be given to the youngest layer. So moving on, we actually don't have to read page 463. It's 2 questions that we're not answering. So skip to 464. And let me just unstaple this really quickly so I can read the text. So on page 464, we're going to be looking at some examples of different rock formations from around the world. And like I said, if you want to see it better, the online textbook has these pictures. And you could also Google pictures too. So I think that would be a good idea. Like for this one, we're talking about the Grand Canyon. Google pictures of the Grand Canyon and you'll be able to see the actual layers and the colors, because I'll show you what it looks like in my book. And it's really helpful to see the colors, especially for this picture here, the rocks in the Painted Desert in Arizona. My sister has been to the Painted Desert and her photos from it are just like so pretty. All of the rocks, you can see like their layers and their colors. So here's my book, and you can see like in the black and white picture of your packet, it's kind of hard to tell, like that is a formation of cacti, of some cactuses. And this would be what the Grand Canyon looks like. And then here, the Painted Desert, you can really see the formations and the layers better when you have a color picture. So I will begin reading, and then I'll show you the other pictures as well when we get to that page. Some rocks and fossils from around the world. Rock layers are found all over the world. Many of these rocks contain fossils. Fossils provide clues about the ages of the rocks in which they are found. That's a really important piece of information, because that's how scientists, like archaeologists, can date rocks based on their fossils. Look at the map and photos and read the captions to learn about some rock formations around the world. Look for patterns in the rocks shown. So this is a map showing us where the different places are. So just for reference, looking at this map, we are about right here where that little pink dot is on the coast, the east coast. About right there is our estimate. So the Grand Canyon and the Painted Desert, these two, very close to each other. Badlands National Park is somewhere in the middle of the country, just like the Niobrara Chalk Formation. We're going to be looking at a chalk formation in Hunstanton, England over here in Europe. And we'll be looking at Golden Gate Highlands National Park, which is in this continent. Do you know which continent that is? That is Africa. So we'll be looking at one in Africa as well. So 4 of what we're looking at are in the United States. This is where we are. And then 2 of the formations are in different countries on different continents. So first, I'll read the caption here. Some rocks in the Grand Canyon in the southwestern United States contain many fossils, but there are no dinosaur fossils. Why? The youngest fossils in the rocks are 270 million years old. Dinosaurs lived 230 to 65 million years ago. So what is like insanely crazy to me about the Grand Canyon is the fact that it is older than dinosaurs. Like the youngest fossils that are in the Grand Canyon are older than dinosaurs. So we can't find dinosaur fossils in the Grand Canyon because it's older than them. So that just shows you how old that rock is and how long it's been there and been weathered down for. The rocks in the Painted Desert in Arizona contain fossils from a time period spanning millions of years. The oldest fossils are older than dinosaurs, while the youngest are just a few thousand years old. So these rocks have been forming for a long, long time, and the youngest ones are only a few thousand years old, which for us, that may sound really old, but for rocks, having layers that are that young is very interesting compared to the Grand Canyon, which isn't very far from the Painted Desert, but it doesn't have young rocks like that. The Niobrara chalk in Kansas, Nebraska, and other states is made of millions of fossils of marine algae. This means that Kansas and nearby states were once on the ocean floor. That is insane. I'm going to just highlight is made of millions of fossils of marine algae, and Kansas and nearby states were once on the ocean floor. Now, for us, it's kind of hard to be familiar with Kansas because we are on the East Coast and we're used to seeing the ocean and water. Kansas is in the middle of the United States, and there's no ocean around. So the fact that there's marine algae, marine relates to the ocean, scientists can tell that the United States used to be underwater. That's a crazy thing for us to be able to understand based off of looking at rocks. The Badlands of South Dakota contain young fossils of the close relatives of modern deer, horses, mice, and turtles. So in the Badlands, let me show you these pictures too in the book. So that's the chalk formation, and here's a picture of the Badlands, which is also like a very rocky part of the United States. And we can tell that some of these extinct animals really resemble modern deer, horses, mice, and turtles. So those are the types of animals that they can find fossilized in these rocks. The Ferriby Chalk Cliffs in England were part of the ocean floor about 100 million years ago. Fossils of many ocean plants and animals are embedded in this soft rock. So there's another part of the world that we can see used to be underwater. this part of England here. And look at the layers in this rock. That's a very thick layer right here. And another thick layer. So in looking at the Niobrara chalk in Kansas, it has very thin layers of rock. And looking at these chalk cliffs in England, both of them are made of chalk. This one has really two just distinct thick layers of rock. So you can see the difference in the ways that they were formed, which is insane. And here's the mushroom rock that we saw at the beginning. The mushroom rock formation in South Africa is home to the oldest fossilized dinosaur egg nest found to date. The nest is 190 million years old. That's crazy. The oldest fossilized dinosaur egg nest. So, I mean, a takeaway that I get from reading this unit is that sometimes we think rocks are just rocks. Like, you never understand how much you can learn from studying them and how much archaeologists understand about our Earth based on looking at these rocks and drawing conclusions about things in our Earth. Okay, number 14, look again at the photos of the rocks and reread the captions to complete the table below. So, for number 14, what I would like you to do if you're watching this video is you have a location and a description of rocks and fossils. I'm going to show you an example for the Grand Canyon of what I would put here as the description. And then after that, I think that you should try these yourself and then unpause the video to see how I go over it. So the Grand Canyon in the Southwest United States is actually on the back. Here's everything about the Grand Canyon. So what would be my description of the Grand Canyon? Some rocks in the Grand Canyon in the southwestern United States contain many fossils. I think that's important. So I would say, like, the rocks contain many fossils. The youngest fossils in the rocks are 270 million years old. So I'll show you how I shorten that to fit it in the box. I'm going to say, and in these boxes, just by the way, you don't have to always write complete sentences because there's not enough room for it. I'm going to say, rocks contain many fossils, youngest are 270 million years old. So why don't you pause the video here, give these a try by yourself, and then you can see like what I write in the boxes. I'm sure it will correspond or be similar to what you write because some of these captions are very short, so just pick out the important information. And even you can look at the pictures too and use the pictures to help you describe the rocks as well. Okay, so for the painted desert in Arizona, something that I would say is that the oldest fossils are older than dinosaurs. And for me, I can more easily describe the picture too. I would say that the layers are thin. In the picture, the rock layers are very thin and they're gray. So I would say gray, thin layers of rock. And I would also say fossils are older than dinosaurs. And then some younger, because the Painted Desert has some very young layers of rock as well. Next, the Niobrara Chalk in Kansas. We actually highlighted some important stuff there, which can help us here. I'm going to write fossils with marine algae. And also in the picture, I pointed out that it has very thin layers. So we can put that it has thin rock layers. Moving on to the Badlands of South Dakota. Something important was that we saw close relatives of modern deer, horses, mice, and turtles. So I'm going to shorten that and say contains relatives of modern mammals. Or I'll just put modern animals because it's mammals and reptiles. Contains relatives of modern animals. And you might have wrote something different. Maybe you looked at the picture and described it. That's okay. I mean, these are just sample example answers. You don't have to have exactly what I have. I'm just showing you what you could have written. Or if you were stuck and you turned to the video to just help you fill this out, that's fine too, as long as you have an answer. So it could be your own, it could be mine. It doesn't have to be what I have because you probably have some great answers as well that are different than mine. Okay, so the Farabee chalk cliffs, I'm going to say first it has like thick layers of rock. And then we also saw that it had ocean plants and animals, which are marine life. So I'm going to say thick rock layers with fossils of marine life. And the mushroom rock in South Africa. Also thick layers of rock. And remember, in looking at the picture, they were different colors. So thick rock layers. I'm going to put colorful. Contains dinosaur fossils. So just brief descriptions of what you see in the pictures. If you need to pause it here, then you can to finish filling it out if you were taking some of my examples to help you. But I'm flipping to the next page to keep moving on because we have a lot more to do. Patterns in rock layers. You have learned that some rocks are very similar to one another, while other rocks are quite different. Some rocks contain fossils of similar ages. Other rocks contain fossils of different ages. So we have the Grand Canyon here. We have the Niobrara Chalk Formation and the Farabee Chalk Formation. We're going to look again at the photos and look for patterns from your observations to help you answer the questions. So what are patterns that we can see in these rocks? Maybe take a minute to pause and think about it yourself, and then unpause for my description of what I see in the patterns of the rocks. So what I noticed in the patterns of the rocks is that I see what we talked about yesterday, like horizontal layers, like layers going across. What I notice as well is in looking at the mushroom rock, you can see how like it's very broken up, and it was hard to tell what was the youngest and the oldest because they're kind of like, they're not going straight across. This one hits, touches the ground. This one touches the ground. It was a little bit difficult to determine age. Well, here, especially the Farabee Chalk Formation, we really see 2 distinct layers. In the Niobrara Chalk Formation, we see very straight lines. It doesn't look like it's hard to tell the youngest from the oldest if we were looking at it because the lines are very clear and distinct. And same with the Grand Canyon, we really see that line going straight across, this line going straight across. So those are the patterns that I see that help me determine kind of what's the same about them, because we're looking for similarities in our observations. So for number 16, choose the words or phrases to correctly complete each sentence. Once again, I always read through the whole thing before I answer. These rocks are made of layers that are blank. The layers in two of the photos are blank in color. Okay, well, you're going to need help with the color part because everything here is black and white. The light layer in the Farabee Chalk Formation is blank than the other layers. First, let's see how we can describe all the layers. These rocks are made of layers that are blank. So I'm thinking of which word fits the best. These rocks are made of layers that are light. I would say this one is very light. I'll put this back. And here, let's do something like that. Okay, so I would say the Niobrara Chalk Formation has light layers, but in the Grand Canyon, there's a lot of dark layers in there, so they're not all light. Thinner, we see thick ones here, so that word's not going to make sense. Bent doesn't work because not all of them are bent. We can see a little bit of bending going on in the Grand Canyon, but for the most part, very horizontal. Nothing bent about this one. Very clear layers here. The best word I can describe all of them is flat. The layers are very flat. We can see clear differences between the layers. The layers in 2 of the photos are blank in color. Okay, well, in describing color, we wouldn't really describe colors as thicker, bent, or thinner. So we have black and light. I would say 2 of them do have lighter color, and that would be the 2 chalk formations. So also think about the word chalk as well. Chalk, we know, is pretty light. So it makes sense that the chalk formations have some light layers. The light layer in the Farabee Chalk Formation is blank than the other layers. So we used light. Is the light layer thinner than the other layers? Bent than the other layers? That wouldn't make sense. Black than the other layers? No, because it's a white layer of chalk. Thicker than the other layers. Look how thick it is compared to the other layers of the rock. All right, moving on to our last page here. Forces and processes on Earth can cause rocks to change. Forces and processes would be like examples of forces and processes would be forces. I think of strong weather, an earthquake, like a tornado, a hurricane. Strong weather forces can really damage rock or change it, and we would see that in the layers. Processes, sometimes processes are simple as simple as just water flowing. And that's how the Grand Canyon changed, because water just flowing over time slowly and slowly eroded away the rock, which means took tiny pieces slowly and slowly over time until the canyon was formed. So forces would be like a major change. Processes would be more of like a slow change. What might happen to rocks when forces act on them? So some rocks will bend due to temperature and pressure. So pressure can happen for different reasons, and it might force those rocks to bend. And I'll show you the picture in my book as well, where you can see in color that we can see like the layers, instead of being flat like what we've seen, they're going like inwards. Like you can tell that rock was affected by something. Others will break and crack during an earthquake. So if there's a shift in the earth, then it might shift those rocks. And look at here, it's very interesting that we can see the differences in the layers. They're not meeting up anymore. It looks like this layer should be meeting up with that layer, and the earth changed them, and now it's all kind of jumbled and discombobulated, and we can tell that some major force acted upon those rocks in the past. All right, we have 3 more questions to answer. For the sake of this video not being too long, I'm going to go through them very quickly. So I would say try them yourself first and pause the video, and then unpause to go over the answers. Number 17 says, look again at the photos above. Compare them with the other photos you've seen so far in this lesson. Use your observations to complete each sentence with the correct word. In rock layers that have not been disturbed, the oldest rock layers are at the bottom, and the youngest rocks are at the top. Due to heat and pressure, I saw pressure up here, and I remember that they were bent. So due to heat and pressure, some rocks often bend, and an earthquake may crack rocks. Number 18, how does finding rock layers made of different types of rock provide evidence that the landscape has been changed over time? That's a mouthful. Really what we're asking is, how does looking at rocks help you know what happened in the past to the earth? Well, if a rock is bent, we know that maybe there was some kind of pressure or force applied. So bent rocks can show us that rocks had heat and pressure in the past. All you really need is one sentence here. I mean, they give you 2 lines. Another thing that you could say is that cracked rocks could show us that there was an earthquake. So this is like an example of one thing that you could have had. You also could have written rocks that are cracked could show us there was an earthquake long ago. And that's how the landscape of the earth changes. For number 19, very quickly going through the answers, rocks in the Grand Canyon are layered. Layered means we can see like the different layers inside of it. We can clearly see that there is a separation between parts of the rock. The oldest fossils in these rocks are found in the bottom layers. Broken rock, let me just cross that off. Broken rock layers show that forces have caused a change in the layers. So, I mean, It could have been an earthquake. Putting were bent by earthquakes doesn't make sense in this sentence. When we see broken rocks, we can assume that there was a change in the layers, like up here. Maybe rocks in something like this, it could have been an earthquake, or it could have been something else. If we see broken rocks, we just know that there was a change that occurred in the past with some kind of force or other process. So that completes part 1, day 2. Please look out for the other science videos that I'll be posting. I'm going to try and post them before Monday so that you can have them ready for you if you're starting part 2 on Monday, which part 2 needs to be or should be completed by next week. So I hope that these videos are helping you. Thumbs up to you guys. You're doing an awesome job, and I miss you so much in the classroom. Stay safe and healthy, and I'll see you guys soon.